Hello, hi, I'm Punita here from Huawei Global Training Center, and today we're going to discuss about the content eNodeB radio data part 14. So let's learn about LTE PRACH. This is the physical random access channel. So UE send preamble signatures and cyclic prefix on the PRACH. Preambles are generated based on the root sequence, the coverage, configured for the cell. So a guard interval is reserved for the PRACH so that preambles sent by the UEs can fall within the time window when arriving at the eNodeB. So they allocate 6 RBs for that. This is the cyclic prefix. So if you have a shorter delay, you use normal CP. If you have a longer delay, then you use extended CP. So this is the preamble sequence that we reserve for the UEs, and this is the guard interval. So receive time window is 1 millisecond. So preamble is basically, in order to access the network, you need to send a preamble message first. That is what we call it random access channel in order to access to the network. So this is the PRACH format. So we have format 0, format 1, and format 2, and format 3. All of them are based on the coverage radius as well. So most commonly used will be format 0 because it's less than 15 kilometers radius. So this is the format decision. So guard period in PRACH determines the maximum round trip delay. So usually for LTE network, the round trip delay is about 30 millisecond to 50 millisecond. So this is a standard. So it limits the maximum cell radius. So this is the equation based on 3GPP. So most of the time we will use the standard preamble 0, which is cell radius less than 15 kilometers. The PRACH format decision is based on the practical coverage radius. So standard we use format 0. Root sequence index planning. So root sequence index is the key part of the PRACH configuration. So it is used to determine the preamble sequence used for random access under the cell. So how many preamble sequence that you need to send? What is the maximum? So there's a calculation here. So basically, the sequence generation is based on the PRACH format, root sequence index, high speed flag, and NCS configuration. So each cell has the 64 preamble sequence. So this is standard. So how to get the NZC? ZARDO2 sequence is defined by the protocol based on the preamble format. So this is a format. So 0 to 3 we will use 839 by default. Number 4 is 139. So random access sequence length. So how to get the NCS value? NCS is related to cell radius and maximum delay spray. It practically allows the creation of several random access preamble on one root sequence. So there are 16 NCS configuration defined in the protocol. So this is all based on the 3GPP standard. All based on the 3GPP standard. So total there are 16, 0 to 15. So this one is 16 NCS value. So based on the cell radius. So depending on the cell radius parameter. So this one is for preamble format 4. This one is for preamble format 0 to 3. So we are using this mainly. So this is the relationship between the cell radius and NCS. So maximum cell radius for given NCS is calculated based on this formula. So if I'm using about 10 kilometers, so it will be 76. If I'm using 12.2 kilometers, it will be 93. So for format 0, this is the range. So the NCS will be 119. So it's between 14 to 15 kilometers. So format 0 will be NCS 119. And extended range is actually from format 2, 1 and 3. So they have the limitation based on the NCS, limitation based on the preamble format. So PRACH planning process. First, you have to determine the PRACH format. Second, determine the NCS value. Then calculate the available preamble number for each root index. After that, we calculate the necessary root sequence number for each cell. Then we determine the root sequence index assigned to the cell. So this is the final one that we configure at the cell level. But before that, you need to determine what format you are using, what is the NCS value based on the coverage radius. So this one is based on the coverage radius and the format. Then we have to see how many preamble number that will be given for the root index out of the 64 preamble sequence for each cell, and what is the necessary root sequence number for each cell. After that only we will configure to the cell level. So these are the planning process. So root sequence index selection. So this is a sample on how they calculate. So let's do an assumption. Preamble format 0, maximum cell radius is 4.5 kilometer. So what is the NCS value for 4.5 kilometer? And high speed flag is low speed. So for cell radius 4.5 kilometer, the closest NCS is 46. So we can see from the 4.5 kilometer is more closer to this value. So NCS is 46. We take the higher one. So step 2, from one root sequence we can create 839 because this one is preamble format 0. So for preamble format 0, total is 839. You can see from the formula here, it is total 839 from the preamble 0 to 3. So we divide by NCS 40. So we have 46. So we have 18 random access preamble. So to have 64 different preamble per cell, so we need to reserve 64 divided by 18, 4 root sequence for each cell. So the available root sequence could be 0, 4, 8 up to 832. And we have 838 divided by 4. So we have 4 root sequence index. So we can use 209 unique configuration in the network. So basically this is how they calculate the root sequence index selection. After that you have to configure that value in the cell level, root sequence index. So the parameter indicates the first logical root sequence index which used to generate preamble. We start from 0 maximum up to 837 or 838. Alright. So let's look into the cell level, what they have configured. So root sequence index we have to add here. So when I list the cell, I'll be able to view the root sequence index. So let's assume that I want to look for cell 0. So I can look into the root sequence index configured for this particular cell 0. So we have the root sequence index here. So one is 0, another one is 1. So this is the root sequence index configuration. So Q&A session. So root sequence index is the key part of the PRAJ configuration. It is used to determine the preamble sequence used for random access under the cell. Yes or no? Yes, this statement is true. So the summary of this section is that we have learned about LT-PRAJ, PRAJ format decision, root sequence index planning, how to get NZC, how to get NCS, what is the relationship between cell radius and NCS, what is PRAJ planning process, what is root sequence index selection example, and how to set PRAJ related parameters. That's all from me. Hope you enjoyed the session. Thank you and bye.